All right, this is second derivatives implicitly, and so these can be long or they can be short. So make sure you get some water. Get ready to hit pause and take a break every now and then. But this is going to be some work. It's very fun, very cool stuff, though. All right, so we're going to be taking the derivative with respect to x. So that means our y prime is going to be our dy dx. So let's start with this. X to the fourth would be 4x cubed. So our x to the fourth plus y to the fourth equals 16. And we're doing our dx. Okay, plus, and then so it would be 4y cubed, and then we have to put y prime because it's not an x, equals 0. So that's just the first part. We found our y prime. Now we need to solve for it to get a formula for y prime. So we get 4y cubed y prime, and then we move the 4x cubed over. And then our quick little divide, y prime equals negative 4x cubed over 4y cubed. We can simplify that a little bit. So we end up with negative x cubed over y. Now we can find our second derivative. So if you take y prime and you take the derivative of it, you get your second derivative, which is y prime. So we end up with negative x cubed over y cubed for our first derivative. So taking the derivative with respect to x, of our y prime would give us our second derivative. So again, we're doing the derivative with respect to x. So we have negative x cubed as our numerator, y cubed is our denominator. So we know this will become y to the sixth because we have to square the denominator. So it's going to be our little quotient rule. So this is negative 3x squared. 3y squared, but that is not an x, so we have to put y prime. And then we do our little multiply. So that's negative 3x squared y cubed plus 3x squared cubed y squared y prime. Now you got to be very careful with these because there's a lot of substituting going on, and so one little tiny error and it's not right. All right, so let's just double check everything. That's negative 3x squared. That's 3y squared. We got the y prime, perfect. And then that one would be negative, perfect. And then a negative, that would be negative, but we're subtracting, so it turns into a positive. And we get 3x cubed y squared y prime. Looks good. So now the second part of this part is to substitute your y prime. So we already know what y prime is. It's right here. And so now we just have to plug it in. So y double prime is equal to negative 3x squared y cubed plus 3x cubed y squared. And then we plug it in, negative x cubed over y cubed. And then that whole thing is being divided by y to the sixth. So now here's where the fun part comes in. We're just going to do some simplifying. So y prime, double prime, equals negative 3x squared y cubed plus, and then this will cancel those two, giving us a minus 3 x to the sixth all over y. And then y to the sixth, because we're left with a y for the denominator. Now, to get rid of that y, we just multiply everything by y. So y double prime equals, and we're just going to multiply top and bottom by y. And so we end up with, I like doing that, negative 3x squared y to the fourth now, minus 3x to the sixth, all over y to the seventh. So we multiplied top and bottom by y. Okay, now if you notice on the top, they have a common factor of negative 3x squared, and you do want to factor those out with these, because what kind of happens is that original function can sometimes be substituted in as well. So you always want to think, can we get rid of the y? That's the key. Or can we get rid of anything in this? So if you notice, we know that x plus y to the fourth is equal to 16. Well, if you look here, we have x to the fourth and y to the fourth. So that would equal 16. So y double prime equals negative 3x squared, and then x to the fourth plus y to the fourth from the original equation is 16. So we end up with y double prime equals negative 48 x squared over y to the 7th. And that is the derivative of our derivative. So there you have it, an example with everything.